So in this lecture we will discuss the top-down splaying method of deletion, right? We have already discussed how to perform deletion in splay trees in the previous video, and in that video we have discussed the deletion with the help of, you can say, that bottom-up splaying, right? Now second approach to perform deletion in splay tree is top-down. Now how to perform deletion using that approach, that we will discuss with the help of this example, and I am going to delete first of all 16, then 12, then 7, right? And after that I am going to write down the steps of this top down splaying method, right? Now see, first you want to delete 16, so now the first step in this method is what? Search where is 16, right? Same step that we have discussed in previous method also. Now searching means this is a binary search tree, right? So how to do the searching? 16, compare with this root node. 16 is greater than 12, right? Greater than 13, right? To this, greater than 14. Here we got 16, right? Now here we will not delete this 16 and replace it with one of its child, maybe in order predecessor or successor. No, that is in bottom up splaying. In this top down splaying approach, we will splay this tree on this element. Or you can say we will splay this 16, means before deletion we will splay the 16. It means we are going to make the 16 as root of the tree. Obviously that splaying means, right? So now which rotation you need to perform, how to do splaying, that also I have discussed with help of example as well in the previous video. You can check out that video in the side button, right? Now see, 16, check 16 is having parent as well as grandparent. Now how you will check that 16 is having parent as well as grandparent? Check parent of 16. If parent of that node you want to delete is not root node, it means obviously that would have grandparent if this is not root, right? So now this is what? And 16 is to the right of 14 and 14 is to the right of its parent. Both are at the same side. So it is what? Zig-zag situation. So here which rotation you need to perform? See, 16 is to the right of 14. So here first of all we will do this 2 left rotation you require. Left rotation on grandparent, after that left rotation on parent. So now after first rotation the tree would be, now we will do second left rotation on this parent. Now again left rotate this parent, that is 14. So we will pull this 14 downward, so 16 would go upward. So now the tree would be, see, the 16 is having left child, that is 15. So after going upward, now the left of 16 is 14 and this 15 would go to the right of this 14, right? So now this is not yet done because 16 is still not the root node. Now which rotation you need to apply? Now 16, check out, parent of 16 is root. So it is zig situation. It is not having any grandparent. Now this 16 is to the right of its parent, so we will do left rotation. So it is what? A zig situation or zig rotation you can say. Now after left rotation the tree would be something like this. 12 would go downward, 16 would go upward. Now see, the 16 is now the root. Now we are done with the splaying. Now you can delete the 16, right? Now we are going to delete. If we can delete it, see, you cannot say that it is a binary search tree and in binary search tree we cannot delete the internal node. So this is something different. Here in splay trees, after this operation you can delete the internal node, right? Obviously we will delete, in this approach we are always going to delete the root element, right? If you follow this top down splaying approach. Now after deleting the 16, suppose I have deleted this 16. Now we have two trees. One is this one. This is the left subtree of 16. This is the right subtree. Now you have to perform join operation on these two subtrees. Now how you will join these trees? See in the left subtree, here the values are always less than this right subtree, fine. So now in join operation, first step is what? From the left subtree find out the maximum element first of all, right? So here the maximum element from this is what? 15. Now splay this 15. Now we are going to perform splaying on this tree for this element, that is 15. It means you are going to make this 15 as a root of this tree. Now how to do splaying? check 15 is having parent as well as grandparent, because this is now the grandparent. After deletion of this is left subtree, and root of left subtree is 12, root of right subtree is now 17, right? Now 15 is to the right of 14 and 14 is to the right of its parent, means both are in same direction, so it is zigzag situation. Now which rotation? 15 is to the right of 14, its parent, so we will do left rotation. So now in this case, first of all we will do rotation on grandparent, then on parent. In zigzag rotation, we first of all rotate parent, then grandparent. Now left rotation on 12 first of all. So now this left subtree would be, right, again second rotation, left rotation, because here we need to perform two left rotation, left, left. So again perform left rotation on 14. So now the tree would be, so now this is the left subtree, this is the right subtree, right? Now second step in join operation is what? Now see, in the left subtree, now the right part of this root is null, right? So we are going to attach this with this 17, means 17, or you can say that the root of right subtree now becomes the right child of the root of the left subtree. So now 17 is to the right of this one. Now this is the tree after deletion of the 16. So now next element you want to delete is 12. First step is find out where is 12. Less than 15, less than 14, here we got 12. Now before deletion we will splay this tree for this 12, right? We are going to make this 12 as root of this tree. So now which rotation you need to perform? This 12 is having parent as well as grandparent, both are at same side, so this is zigzag rotation. Now both are at the left side, so we will perform two right rotation. First right rotation on 15, then right rotation on 14. So after both the right rotations, the tree would be something like this. I am writing that final tree here. So now from this tree, now 12 is the root. Now you can delete this 12. Now after deletion of this 12, now we have divided this tree into two subtrees. One is this left subtree, one is this right subtree. Now you have to perform join operation. Now in join operation, first you need to do what? First step is from the left subtree find out the maximum element and splay the tree for that maximum element, or you can say splay that maximum element. Now here the maximum element is obviously 10, so splay this 10. Now 10 is already root of this left subtree, so no need to do any splaying, right? So left subtree is same like 10 and 7 after splaying, or obviously we didn't have any splaying because 10 is already root, right? So it will return simply the address of this root. Fine. Now the right subtree is having root 14. Now as we know, these are two subtrees. Suppose this is S, this is T. So all the element in S would be less than T. Now see, the root of left subtree, the right child is null. So now the right child of this is what? This would become the root, and the right child of this 10 would be this, the root of the right subtree, that is 14. So now this is the final tree after deletion of this 12. Now suppose I want to delete 7, right? Now find where is 7. Here we got 7. Now splay this tree, make the 7 as root. So now the tree would be, see here 7, the parent of 7 is root only, so this is a zig rotation. Now 7 is to the left of 10, so we will do right rotation. So after right rotation, one right rotation, the tree would be something like this. Now 7 is what? The root, so now you can delete this 7. Now here see, we don't have any left subtree because this is what? Null. There is no left child of this 7. So after deletion of this 7, there is no left subtree. Now have to perform join operation. In this case, if this is the case, then simply the root of the right subtree would become now the root of the tree, right? So now the tree would be this one. Now suppose the situation is we have left subtree but we don't have right subtree. In that case, it is not like that simply the left subtree would be the that tree, or you can say the root of the left subtree would become the root of the tree, as like in this situation. No. If the left subtree is present, in that case you must find out the maximum from that left subtree and splay that left subtree for that maximum element, right? After that, the maximum element, after splaying, the maximum element from the left subtree would become the root of the left subtree, right? And if there is no right subtree, then obviously the root of left subtree now becomes the root of the tree, right? This thing you need to take care. Suppose here I want to delete this 17, right? First of all, find where is 17, greater than 10, greater than 14, greater than 15, and here we got 17. Now splay this tree for this 17, means splay the 17. Now this is having parent as well as grandparent, both are to the right side, so zigzag rotation would be there. Now both are right side, so 2 left rotation would be required. So now after 2 left rotation, the tree would be, but this is not yet done, 17 is still not the root. Now make it as a root. So for this, the parent of the 17 is root, so that is a zig situation. This is the right side, so we will do left rotation. So after left rotation, the tree would be, so now this is the tree. Now I want to delete, suppose I have deleted this 17. Now there is left subtree, but there is no right subtree of this 17, right? Now what you will do? Now how to perform join operation? Same steps you would follow. Find out the maximum from this left subtree, maximum is 15. Splay this left subtree for this 15, right? So now after splaying, the tree would be, after splaying of this left subtree, the tree would be, see the 15 is to the right of this 10 and 10 is root of this left subtree, so this is zig rotation, so we will do left rotation only. Now the root of left subtree is 15. Now the right child of this is null, so what we do in join operation? Make the right subtree as right child of this 15, but there is no right subtree, so this is now the tree. Now make this root of the left subtree as root of the tree, so now this would become our tree after deletion of what? 17. So now if you write down this procedure in the steps, then what you can do in the delete operation? See, first what we have done, splaying operation, the algorithm for splaying I have already discussed in the previous video, where we have discussed how to do insertion in splay tree. Fine. See, insertion is also having 2 approaches, and deletion we can also perform with the help of 2 approaches, right? So in this case, first of all, obviously you will check if root is null, there is nothing in the tree, then we cannot delete anything, right? Now, so you can simply write down, if root is null, then simply return null, right? Now here, see, second situation may be, suppose from this tree I want to delete 20. Now search where is 20. It would be greater than 15, but there is no null child of this 15. We don't have 20 in this tree, right? So in that case, it's not like that you will leave this tree as it is. If you searched an item and that is not present in this splay tree, then also you need to perform splay operation. Now on which data you need to perform splay operation? Suppose I want to delete 20, so 15 greater than 15, but here we have null. So before reaching to the null, the lastly accessed not null element is 15. So you will splay this 15, right? But in this case 15 is already root, so no need to do any splaying, so this would be as it is. Suppose here I want to delete 11. Search where is 11. Less than 15, greater than 10, less than 14, less than 13, but here we have null. We have reached to null. So 11 is not present. So before reaching to null, the lastly accessed element is 13. So we will splay this tree for this 13, right? Now this 13 is having parent as well as grandparent. So this is what parent, this is left of this one, this is right of this one. So this is zigzag rotation. So after the rotation, the final tree would be, but we are not done yet because 13 is not the root. Now which rotation? The parent of 13 is root. So now this is zig rotation. So 13 is to the left of this one, so we need to do right rotation, one right rotation. So after right rotation, the tree would be, see this 14 is to the right of 13, it will go to the left of this 15 now. So now this is the tree. Now search, the key you want to delete is 11. Now search if the root is the data you want to delete, but root is not that data, means we cannot delete anything. Now here you can, your program or your algorithm can print that key is not, or the data you want to delete is not present in this tree, right? You need to take care all the cases when you are writing a program. So now if root is not null, see in this case we want to delete 16, root is not null, we have tree, so we will splay this tree for the 16, right? Obviously we will search for the 16, and that thing we have already discussed in splaying algorithm. So here I just want to call this that splay operation, right? On this tree, or you can say that root of the tree, you can pass, or t you can pass, and the key you want to delete, or you can say the data. The data is 16 here, so I will pass the data, or it depends how we are going to implement it. You can pass the address as well, or you can take both are pointers, or here you can take this is pointer, this is simple a variable that contains the data, right? It all depends on how you are going to implement. I am just writing a general case. I am not saying that this algorithm or this would be correct, right? I am just writing down the steps. So now after splaying, see this case, after splaying we will compare this 11 with this 13. If the data is not equal to root of data, it means key is not present. Now if the data, suppose 12 you want to delete, and after splaying now this 12 would be the root, right? So now it is equal to the root. Now you can delete it, and now the tree would be left subtree and right subtree. So now here also we have some cases, like if the left subtree is null, in that case what you will do, like here we have done, in this case when we deleted the 7, the left subtree is null. So here we simply done what, we return that this would be the root of the tree. So now this thing how you can write down, if root of left means root is this one, right? Root of left, this pointer is null, in that case what root becomes this one now. So root of right, the address of this node would be here in the root of right pointer, right? Because this is node obviously, right? Root means I am containing the address of this one, address of this node, not the value 7, right? So now root of right becomes root, fine. Else we will take another pointer variable temp, and there we store root. So root is also here now, and temp is also here, you can say something like this, right? Now else what you need to do, we will find out, see here you can say we will find out from the left subtree the maximum one and splay that left subtree for that element, right? Now here simply you can do, you can write here splay the root of left, means the left subtree we are going to pass the address of root of left. For which key, for which data, or you can say here you can write the data you want to delete. So now this splaying operation will do all the steps like finding the maximum and splaying for that thing. Why I am writing the data? See, suppose here when you want to delete this 12, so the data is 12. So now after reaching here, after splaying, this is would be the left subtree, this would be the right subtree. Now if you splay this left subtree, the root of left subtree is 10. For this data, that is for 12, it means here find out where is 12. 12 is greater than 10, but here we have null. It means 12 is not present, so we will do what? Splaying on the element which is lastly exist, means lastly not null exist. So that is 10, so we will splay for this 10. And if you find out maximum from this tree, maximum is also 10, so you need to do splaying for this 10. Both are same, right? So you can write down this thing also. We can splay that left subtree on the data. After splaying, see this root of right means this would contain address of 14, but now this address, now 14 should be the right child of this 10, right? So where you will store address of this 14 means where you will store address of root of right, here in the right pointer of this root. This is what? Root of left subtree. Suppose I am taking this as root 1. So root 1 right, there we will store root of right, fine. Root is what? The root of this tree, and root 1 I am taking the root of left subtree, and suppose root 2 is root of right subtree, fine. Now this is done, and after that you can free temp. and return root. So here I have given just the overview of the algorithm of this delete operation, right, that top down splaying approach. You can consider this one and you can write down the proper algorithm, or you can write down the program. See, to convert this into a program, that would be a little bit tough. So you need to take care of all the conditions, all the situations, right. So now this is what the deletion in splay tree following this top down splaying approach. Here in this splay tree, this is the join operation we have discussed. One operation is also there, that is split operation. So that is very easy. So if you want me to make a video on the split operation, you can tell me in the comment box. I'll make a video on this topic also. Fine. So now I'll see you in the next video. Till then, bye bye. Take care.